So we have two equations here. It's ask us to solve for x. Also, we're asked to check solutions if possible. And finally, it says graph your solutions on a number line. So we'll look at that in case there's any confusion about it. So that first equation I'm just rewriting down below here. It's negative 2 times 4 minus, negative 2 times the quantity of 4 minus 3x, and then minus 6x, and that equals 10. And then we have a proportion for the other part B. It's x minus 5 over negative 2 equals x minus 1 over negative 3. The reason why I'm reading is I'm just making sure that this says exactly what this is, because now I'm going to enlarge these and not take a look at that other part. So I guess the first thing I'm going to do here is apply the distributive property to remove these parentheses. So this becomes negative 8 and then plus 6x and then minus 6x, and that equals 10. So if I simplify that, right, 6x's minus 6x's is 0, so I get negative 8 equals the number 10. Well, this is a bad day, right? This is a contradiction. Clearly, negative 8 and 10 are not the same thing, so we would have to say that there's no solution. I don't care what value of x you pick, right? There's no point when this will ever be the same. And the reason why is if you look at it, the x's cancel and you end up getting the two numbers that are clearly not the same. It says they are the same. By the way, if we got a statement like negative 8 equals negative 8, then we would say it's an identity and all real numbers would be solutions. But here it's a contradiction, so there's no solutions. Let's take a look at the next one. This is a proportion, and at a certain point, we may talk about shortcuts more, but as I look at this, the thing that I'm seeing is I would probably right now just choose to multiply both sides of this by negative 6. And if I did that, right, I know that multiplying both the left hand and right hand side by negative 6 will eliminate these fractions. So for example, and again, right, I have equal things. This is a statement saying, hey, these are equal. Assume that these are equal. If they are equal, what's true? Well, if these are equal and I multiply both sides by negative 6, I get another statement that's also true. And to kind of help you see this, what I'm doing is I'm taking this negative 6 and dividing it by negative 2. When I do that, I get a positive 3. So I end up getting 3 times the quantity of x minus 5. Okay. On the other side of this, you can see I've got this negative 6, and I'm going to divide that by this negative 3. There's a giant one here. I'm simplifying it. Negative 6 divided by negative 3 is positive 2. So on the other side, I ended up getting that this is equal to x minus 1 times a positive 2. So I can now go ahead and do multiplication of, I distribute actually the 3 in the one case and the 2 in the other. When I do that, I end up with 3x minus 5, and that equals 2x minus 2. If I subtract 2x from both sides, over here I get an x on this side, minus 5 equals negative 2. And then I can add, oh, I've made a little mistake here, haven't I? Rather than erase the video and like, run away, I can see it myself right here. So since I've caught it and it's relatively early, hey, when you're distributing, you can see how easy it was. I just got carried away, but this is 3 times x and it's 3 times negative 5. So those of you watching it and you were yelling at me like, hey, you're wrong, at least something triggered in me and I saw that. So it should be 3x and then minus 15. Now, again, I'm going to go ahead and subtract 2 x's from each side. So I get x minus 15, and that'll equal negative 2. And then if I add 15 to both sides, right, plus 15 and then plus 15, I end up getting that x is the number 13. So this I can check, right? I can see if this is correct because it says if possible, check your solution and then graph it on a number line. So I'm going to check if this is true. So I'm just going to bring a number 13 up here, and I'm going to place a 13 in for this x and a 13 in for this x, and just verify that this statement of equality is actually the case. So if I do that, let me zoom out a little bit here. In the numerator, I get 13 minus 5 over negative 2, and I'm trying to see, and I'll put a question mark here, if that's the same thing as 13 minus 1 over negative 3. Well, 13 minus 5 is a positive 8, so I end up getting 8 over negative 2, and 8 over negative 2 is negative 4, so I get that on the left-hand side. On the right-hand side, I end up getting 13 minus 1, which is 12, and 12 divided by negative 3 is also negative 4. So since the value of 13 made both the left-hand side and the right-hand side equal to 4, it is indeed a solution. And then in terms of graphing it on a number line, so here's a number line, and I'm just going to real crudely say here's 0, and I'll go, I don't know, 2, 4, 6, 8, 10, 12, 14. So this right here would be the number 13. So the solution on this number line, the point that makes both the left-hand side and the right-hand side of the expression equal to negative 4 is right here. So that's the solution graphed on a number line.